Hello, 6th grade. In this next video, we're going to talk about how we can convert fractions to decimals and vice versa. So we'll start with going from fractions to decimals, and there's really two methods for doing this, and it really depends on what kind of fraction you're given, what method you might choose. So the first method is to find an equivalent fraction that has a denominator of 10, 100, or any other power of 10. So basically numbers that end in a 0. And then once you find that equivalent fraction, you can easily make it a decimal, since decimals are based on powers of 10. So, for example, 3/25. 25 will go into 100 4 times. So what I can do is I can convert 3/25 to a decimal that is over 100 by multiplying my denominator by 4. Because I'm multiplying my denominator by 4, I also need to multiply my numerator by 4, and 3 times 4 is 12. So basically I'm doing the opposite of reducing. Instead of dividing both my numerator and denominator by the same number, I'm multiplying by the same number. 3/25 and 12/100 are equivalent fractions. If we reduced 12 over 100, we would get 3 over 25. But now that I have this fraction written with a denominator of 100, I can express this as the decimal 12/100, which would be 0.12. So 3/25 as a decimal is equivalent to 0.12. There's a second method, though, that we can also use to convert fractions to decimals, and that's by using division. We talked in yesterday's video that a fraction bar indicates division. So anytime you have a fraction, you can always convert it to a decimal by dividing the numerator by the denominator. So if we took the fraction 3/25 and we divided the top number 3 by the bottom number 25, it would look like this. Okay, so we would need to set up this long division problem as 3.0 and then put our decimal point in the quotient like this. 25 will not go into 3, but it will go into 30 one whole time. 1 times 25 is 25. Subtract, I get a 5, and now I can add a 0 and bring down. 25 goes into 50 2 whole times, and 2 times 25 is 50. So you also get 0.12 by doing long division. So it really doesn't matter which way you choose to convert fractions to decimals. You can choose long division or you can choose this first method here. I personally think the first method is easier. However, it only works when your denominator will go into 10, 100, or 1000. Sometimes you have no choice and you have to use long division. Okay, so let's practice this method now. And we're going to practice on these fractions here, 1 through 4. So on example 1, I have the fraction 33 over 500. So 500 is larger than 100, so I can't multiply by anything to get 100, but I can convert 500 to 1000. Okay, I can convert 500 to 1000 by multiplying the denominator by 2. So remember, your denominator can be any number that is a power of 10. If I multiply my denominator by 2, I need to also multiply my numerator by 2 to keep these fractions equivalent. 33 times 2 is 66. So this fraction is equivalent to 66 out of 1000. And 66 out of 1000 is going to be the decimal 66 thousandths. So be careful when you write this. This is not 0.66. 0.66 would be 66 hundredths. We need to make this 0.066 because we need to make sure this last 6 ends in the thousandths place of our decimal. Okay, number 2, we have the fraction 7/8. 8 will not go into 100 or 1000, so we need to use long division to convert this decimal. So it's always the numerator divided by the denominator, so that means we're doing 7 divided by 8. So we'll make 7.0, and then bring up a decimal point straight up into the quotient. 8 will not go into 7, but 8 will go into 70 8 whole times. 8 times 8 is 64. I subtract, I get a 6, and now I can add a 0 and bring down. 8 will go into 67 whole times. 7 times 8 is 56. I can subtract, and I get a 4, bring down another 0, and finally 8 will go into 45 whole times. And 5 times 8 is exactly 40, so we can stop our decimal. So 7/8 is equivalent to the decimal 0.875. 0.875. Okay, number 3, 5/6. 6 will also not go into 10, 100, or 1000, so we need to do long division again. So we're going to do 5 divided by 6, and we'll make 5.0. So 6 will need to go into 50. 6 goes into 58 whole times, and 8 times 6 is 48. So we get a 2, and we can add a 0 and bring down. 6 goes into 23 whole times, and 6 times 3 is 18. 20 minus 18 is 2. We add a 0 and bring down. 6 goes into 20 again, 3 whole times. 3 times 6 is 18. And so now you might notice we're getting a pattern. Okay, we can keep going forever and ever, but every time we're going to get a 20 down here. We'll have a 3 up in our quotient, and we'll have a 3 times 6 is 18, so this will keep on repeating. So this actually becomes a repeating decimal. Okay, it becomes a repeating decimal 0.83, and the 3 becomes the repeating part. So once you notice this pattern, you can stop dividing, and we can write that 5/6 is equivalent to the decimal 0.83 repeating, and we put a repeating bar on top of the 3, because the 3 is the part repeating. Okay, number 4, we have 23 over 99. 99 will not go into 10, 100, or 1000, so I need to, again, do long division. So we're going to do the numerator, 23, divided by the denominator, 99. So we'll make 23, 23.0. Use your estimation skills. 99 is close to 100. 100 will go into 232 whole times, so let's try a 2 here. So 99 times 2 is going to be 198. When I subtract these, I get 32. Can add a 0 and bring down. So 99 into 320, that should be 3 whole times. (99 times 3 is 297. And the difference here is 23. I can add a 0, bring down. 99 goes into 230, 2 whole times. We already know 2 times 99 is 198. 230 minus 198 will be 32. I can add a 0 and bring down. 99 goes into 320 3 whole times. And again, 3 times 99 is 297. So I could keep going on this problem. If I kept going, though, you would see that we're going to end up getting another pattern. And our pattern is going to be 0.23, 0.23, 0.23, 23, 23, etc. So this is also a repeating decimal. This time, it's both the 2 and the 3 that are repeating. So when we write this as a decimal, we can write it as 0.23 with the bar above both the 2 and the 3. Okay, let's look at the backside now and talk about these 2 different types of decimals we saw in problems 1 through 4. So in examples 1 and 2, our result was a terminating decimal. So terminating decimals are ones that end, and every terminating decimal can be written as a fraction with a denominator of 10, 100, 1000, or so on. Examples 3 and 4 that we just did, 0.83 repeating and then 0.23 repeating, those are repeating decimals. Repeating decimals are decimals whose digits just repeat forever. And so we have a different way of writing these decimals as fractions, and that's what we're going to look at in the second part of this video. So going from decimals to fractions now. If I want to express a decimal as a fraction, if it's terminating, then I just need to write that fraction with the denominator as a power of 10, and that's indicated by the place value of the final digit of the decimal. So for this decimal, 0.12, this is the decimal 12 hundredths, and the last digit of the decimal is in the hundredths place. So that means I'm going to write this as a fraction over 100. And the numerator of that fraction is going to be the decimal part of this, the 12. So this is the fraction 12 over 100. And now I want to reduce this fraction. I can reduce this fraction by dividing both 12 and 100 by 4. 12 divided by 4 is 3. 100 divided by 4 is 25. So we get the fraction 3/25. Repeating decimals, however, are done a little bit differently. Anytime we have a repeating decimal, we're going to treat it just like we would this terminating decimal, except our denominator is going to be 1 less than that power of 10 indicated by the number of decimal places. So for 0.12 repeating, I'm going to write this as 12 over 99. 99 is 1 less than 100, what we did up here. And now 12 over 99 can reduce because both 12 and 99 are divisible by 3. 12 divided by 3 is 4. 99 divided by 3 is 33. So 0.12 repeating actually becomes the fraction 4/33. 4/33. So let's practice this now on the last few examples, 5 through 8. We're going to take each of these decimals and write them as fractions. So number 5, the decimal 0.45. This decimal ends in the hundredths place, so I can write this as 45 over 100. And I can reduce this by dividing both the numerator and denominator by 5. So I get the fraction 9 over 20. 9/20 is equivalent to the decimal 0.45. Number 6, 0.6 repeating. Because this is a repeating decimal, I need to look at my decimal place. The decimal is in the tenths place, and so I need to make my denominator 1 less than that, so my denominator will be 9. So this is 6/9 as a fraction. 6/9, which I can then reduce by dividing both the top and the bottom by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. So this becomes the fraction 2/3. Number 7, 0.125. 0.125 ends in the thousandths place, so my denominator will be 1,000. My numerator will be 125. I can reduce this fraction by dividing both the numerator and denominator by 5. 125 divided by 5 will give me a 2 and then a 5. Okay, 5 goes into 125 25 times, so I get 25 over 1,000 divided by 5 is 200. And here we see 25 over 200 are both divisible by 5, so I can reduce again. 25 divided by 5 is 5. 20 divided by 5, 200 divided by 5 is 40. And sure enough, 5 over 40, I can reduce one more time because those are both divisible by 5. So 5 divided by 5 gives me 1. 40 divided by 5 gives me 8. So this reduces to the fraction 1/8 when all is said and done. 0.125 is equivalent to 1/8. Okay, my last one, number 8, I have the repeating decimal 0.234 repeating. So I can make this 234 in my numerator. This decimal ends in the thousandths place here, but because it's a repeating decimal, I need to subtract 1 from 1,000, so that would be 999 as my denominator, 999. Remember your divisibility rules. If I add 2, 3, and 4 together, I get 9, so that means 234 is divisible by 9. as is 999. 234 divided by 9 will give me 26. So I get 26 over 111. 999 divided by 9 is 111. So this is the fraction equivalent of the decimal point 234 repeating. Okay. Any questions you had over this video, make sure you've written those down, and we're going to practice this the next time I see you in class. Until then, folks, have a nice day. You're all wonderful people. Take care.